Hi, this is Miss Downey, and we are beginning Chapter 6, Section 1 of Algebra 2. This chapter is about roots and radical expressions. Our objective is to find the nth roots. So, to begin, I ask everyone to explain and to write in their math journals, what is the cubic root of 125? So, I want them to explain the process of how they solved that problem. Once they did, they wrote this process in their math journal, and then we began the lesson. To begin, we need to understand that when you work with powers, corresponding to every power, it has a root. There is a root for every power. So if I have 5 squared equals 25, then we can say that 5 is a square root of 25. And if I have 5 cubed equals 125, then we can say that 5 is a cube root of 125. And then for a fourth, 5 to the 4th power, 625, then we can say 5 is a 4th root of 625, and so on and so forth. But as we see, a pattern develops, and we can write a formula from this. So this pattern is suggesting a definition for the nth root. So for the nth root, we can say if a to the n equals b, with both a and b real numbers, and n is a positive integer, then a is the nth root of b. And that's what we developed from the previous page. Now there's some properties that apply to this. If this n is an odd number, an odd power, then we can say it has only one real root, one answer. And then if this is an even number, then it's going to have 2 roots, one being positive, one being negative. And we call the positive one the principal root. And the negative is just the opposite of that. Now, if we have an even, let's see what this would look like. Even would be 2. So we could say the square root, being an even, of 4. There we go. So let's look at our first case here. 4 is positive, and this is an even because it's square. We say it has 2 roots, the principal and the opposite, the negative root. So it's going to be a positive 2 being the principal and the negative 2. So it has those 2 answers. Now, what happens if we have the square root? So it's an even index, and I'll go into some terminology real quick. This is called the radicand. The radical sign. What's underneath that is our radicand. And what is right here, like if I wanted a cubic root, this is called our index. If there's no index, it's just assumed to be 2, as in this case. All right. So if we've got a positive index of 2, and our radicand is a positive, so it's a 4, so we know our answer is positive negative 2, with 2 being our principal second root. Now, back to where I was. What happens if I've got an even index and a negative radicand? Well, there is no real root that exists for that, because you can't take something and multiply it an even number of times and come up with a negative answer. Because we're saying, well, what can I multiply, in this case 2 times, and get a negative 4? It just doesn't exist. And remember, we're not working with imaginary, we're only working with the real numbers. So, if it's odd, let's do this one, then there's only one answer. Right? Or it could have a negative, be negative 2. Okay, so there's just one answer if the index is odd. But if our index is even, it can have 2 answers. If this is positive under here, we're going to have 2 answers. But if this is negative, then there is no real root that exists. Okay, any nth root of 0 is always equal to 0. Okay. All right, so problem 1 says what are the real cube roots? So the real, not principal, but real. So of a cube root means it's odd index, so it's going to have only one answer. Of 0.008, so what can we multiply together 3 times and get that? Would be a 0.2. So 0.2 is our only real cube. A 0.008 and negative 1,000 is going to be negative 10 cubed. So negative 10 is our only real cube root of negative 1,000. And 1/3 is our only real cube root of 1 over 27, because 1/3 times 1/3 times 1/3 equals 1/27. So that's when we just have one answer, when our index is odd. Now what happens when they're asking for it to be even? So we're going to have 2 answers or no answer. So what's the real 4th root of 1? So the real 4th root of 1 is going to be positive or negative 1. So we have 2 answers, positive, negative 1. And for negative 0.0001, it doesn't matter what this was. We're asking for an even power of a negative number. So it doesn't matter what this is. There's not going to be any solution. No real root exists. No 4th root exists for them. And then the 4th root of 1681, well, that's going to be 2/3, positive 2/3, and negative 2/3. Okay, and you just have to reverse multiply. You have to think what times what times what times what equals that number. So hopefully for the sake of the exercises, they'll be the smaller numbers, so you've got to get sharp with your multiplication tables if you're not already. Otherwise, this is going to give you fits. Here's our got it to reinforce our understanding. Pause if you want to work this. Okay, so according to the fundamental theorem of algebra, x to the 4th minus 1 equals 0 has 4 roots. But only 2 of those are real. In this chapter, we're only going to focus on real roots only. Okay, so problem 2 is broken down into 4 problems. And so the first, let's see, the instructions were, what is each real number root? So the first one, the real number root, well, we've got an odd index and a negative number. So we know it's going to be a negative 2. One answer. Because negative 2 cubed is equal to negative 8. Right? So we're just reversing the process to find it. B, so now this is a square root, so it's even, and our radicand's positive, so we know it's going to be a positive negative number. So what are we going to multiply together and get that? 0.2. Okay. Oh, did they ask us? Oh, real number root. What is each real number root? So we're just going to give them the positive of that. The positive square root. Okay. Okay, continuing part 2 of chapter 6, section 1, algebra 2. We just finished B, and we determined that answer was positive negative 2. And then now for C, we've got what is the fourth root of negative 1. And when we look at this, we have to realize this is an even index and a negative radicand, so there's no real root solution. And look at D. Now we have to do some math first. This one's a little tricky because we'd want to cancel this out and say, oh, that's negative 2. But you can't. You have to do the math first. So remember, PEMDAS, exponents, parentheses, exponents. So negative 2 squared is a positive 4. So we get radical 4. Now, what's the answer of radical 4? 2. Okay. We're looking for the positive. And that's how you do these sets of problems. There's the got it's here. You can pause and work these if time permits. Moving along, we need to know there's a property for the nth roots of nth powers. And as I just pointed out a minute ago on D, where is it? Right here. You want to be tempted to cancel out the square root and the power and say this is equal to negative 2, but that's not true. Okay, so we just proved, you've got to be careful with those. So when we do these things, we need to realize there's some properties that come out of our nth roots of nth powers. So for any real number a, to take the nth root of a to the nth power, if a is going to be equal to a if n is odd, but then if n is even, it's going to be the absolute value of a. Okay? So let's look at these into motion. Problem 3. When the radicand contains a variable expression, you must include the absolute value when n is even and omit it when n is odd. So we have to look at the simplifying radical expressions. What is the simpler form of each radical expression? And here we've got, what is the square root of 16? X to the 8th power. So what we need to do is realize, okay, this is even index, so it's going to be absolute value. Our answer will be an absolute value. So what we have to do to solve these is, because this is a square root, we have to get the things inside here because we're trying to clear this radical sign. So we have to get it down to squares because that's what we're dealing with. So we've got 16. What can we square and get 16? 4 squared. And what can we square and get x to the 8th? We'll just divide it by 2. That's the trick, right? 8 divided by 2 is 4. So it's going to be 8, x to the 4th squared. So now we have the square root of 4 squared times x to the 4th squared. Now we can rewrite this as 4x to the 4th squared. Right here. Okay. And now we can clear the radical sign and the power. And don't forget, because it was even, you've got 4x to the 4th. Absolute value of, so it's 4x to the 4th. Okay, next. We have B. We have the cubic root of a to the 6th, b to the 9th. So the first thing we're going to do is try to clear these. So what can we multiply by 3 and get the 6? Well, it's going to be 2. So it's going to be the cubic root of a squared cubed and b to the third cubed. And now we can rewrite that as the cubic root of a squared b cubed cubed. And now we can clear our signs and we get, and this was odd, so we just leave off the absolute value and it becomes a squared b cubed. Okay. So when it's even, you add the absolute value. When it's odd, no absolute value, just the answer. So get C. Now we've got, what's the fourth root of x to the 8th, y to the 12th? So we've got to rewrite it first. So what can we get it to the 4th power, right? And what's it going to be? X squared. And then y cubed to the 4th power, right? Because power 2, power multiply, that becomes x to the 8th, y to the 12th. And now rewrite it. X squared y cubed to the 4th power. Now we can clear them. And let's see, it's even, so it's going to be an absolute value, x squared y cubed, which is just x squared y cubed. Oh, excuse me. The y cubed stays absolute value because he's odd. Just the evens. So the index is even, so the absolute value symbols ensure the root's positive, even when y cubed is negative. Absolute value symbols are not needed for x squared since x squared is always non-negative. Okay, so it becomes x squared absolute value of y cubed. Okay, so the absolute value stays on because he is an odd power. Okay, here's the got it's for these. You can pause and do these if time allows. And problem 4, last problem we're going to go through. It says some teachers adjust test scores when a test is difficult. One teacher's formula for adjusting scores is A equals 10 times radical R, where A is the adjusted score and R is the raw score. If the raw scores on one test range from 36 to 90, 36 being the lowest, 90 being the highest, what is the range of the adjusted scores? So you have to decide what to plug in where. So we know our formula is A equals 10R. A is our adjusted score, so that's what we're trying to find. We want to find this. So that means our raw score is the 36 and the 90. So we have to do this formula twice, one for 36 and one for 90. So there's the 36, A equals 10 times radical 36, which radical 36 is 6, 10 times 6 is 60. So the bottom of her test was 60. That's the adjusted score. So the child who made a 36 now has a D. And then the high score was 90, so 10 times absolute value of 90. I'm sorry, radical 90 is about 10 times 9.487, which comes out to about a 94.87, around a 95 when you round it. So the 36 to 90 being the raw scores, the adjusted scores now for her class is a 60 to a 95. So everybody's score, especially on the low end, went up really a lot. So the adjusted scores range from 60 to 95.